All right, last one, guys. Last one. I may have even said that last time, but for this time, I for sure know this is the last one because today is the last day of class before the test. So, let's get started. So, before I continue, little editing jump, sorry. I want you to pause it at each individual slide before I start going over the question, and I want you to try the problem. Okay, if you read it and you're still not sure what to do, then go ahead and play the video, but I really want you to try them first, guys. Get your brain into math mode, get yourself prepared and ready to whoop this test. All right, so first probability question. The two spinners are divided equally as shown. The arrow of each spinner is spun once. What's the probability the arrows will land on a section labeled 1 and a section labeled G? So this is two individual events. We should be able to clearly see that these are independent events nonetheless. So that means that we're going to be multiplying two separate probabilities here. So there are 8 sections on each spinner. And how many of them come out to be a 1 on this one? Let's circle it. 1, 2, 3. This would be a great thing for your highlighter tool on your actual test. And same thing over here. How many of these end up being a G, 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 2 G's? And I can simplify by dividing by 2 and dividing by 2, so I end up with 3 over 32, which is C. That's not a difficult question at all. Okay, so we've discovered that these questions with these graphs can be a bit challenging, so let's go through and read it. The graph shows the median weekly earnings in 2009 in the United States based on education levels. So we got earnings and how much education the person has. So it looks like it's not just a math problem, it's a cautionary tale on why you shouldn't stop getting an education, I guess. As if it's free. You know, of course it's not free, but anyway. Based on the graph, which statement is true? We're going for is true here. A person with a bachelor's degree earned $600 more per week than a person with a high school diploma. So here's the bachelor's degree, which is about $1,000. High school diploma is about $600. That is false because the bachelor's would have to be up to $1,200. So it is not $600 more. That one is false. A person with a doctorate earned $1,000 more than a person with a bachelor's. Doctorate is right up here at $1,500. Person with a bachelor's is about $1,000. So no, that is also false because it's more like $500 more. Okay, and if it helps, go through and actually write in the amounts. Doctorate, bachelor's, 1,000, definitely false. Person with a master's degree, let's write this one in, is about 1,200, maybe 1,250, since it's a little bit higher. Person with a high school diploma, about 650. Person with a master's degree earned about twice. That is close. That is very close, because 600 times 2 is 1,200. So that could very well be it. Person with a doctorate, about $1,500, earned more than 4 times as much as a person with a high school diploma, who earns about $400. No, that is false, because 4 times 400 would be 1,600, not 1,500, and it is not. So that one is false. So we just needed to go through and really analyze this. And what you guys have recognized at this point is that you've got to read and annotate both. A bag contains 5 red balls, 3 yellow balls of the same shape and size. 5 red and 3 yellow. And this is the best thing for you to do in a probability problem like this, is to go ahead and actually copy down the information. Carla will randomly select a ball from the bag 3 times. She will replace the ball each time. Will replace. So she's replacing the ball. What's the probability that Carla will get yellow? You know what? Now I can't actually read what I just... Yellow for the first 2 selections and red on the 3rd. All right, so yellow, yellow, red. And there's nothing to simplify there, kids. 8 times 8 times 8, I think, is 512. And part of me is looking at those answer choices, and part of me is just knowing my times tables. Yep, 512 for the denominator. And 3 times 3 is 9, times 5 is 45. So the answer comes out to be C, and there's nothing to simplify on this one. Okay, so remember, at this point, I just want to remind you, you should be pausing it to try these problems as we go. If you haven't been doing that, do that now for this one. All right, the steps used to solve an equation are shown. So we got 9r equals 54. Someone decided to be fancy and multiply by 1/9. Remember, that does the same thing as dividing by 9. So it really is not any more complicated than what we do when we divide both sides by 9. And then they decided to rearrange a little here. That looks like an associative property step. But look here, this one is in green, and that's what they want us to do, is what happens between 4 and 5. So I like that they're really specific about specifically what happens from here to here, and you've got to identify the difference. And the difference is right here. 1 times r is r. Anything times 1 is itself, and the word identity immediately hops out at me, making sure it's the right operation. That's identity of multiplication. Commutative, remember C for change, O for order. Associative would be what you see right here when they change that grouping. Inverse would be what you see right here when they change that to a 1, because the 1/9 times 9 is 1. But it's identity that we're specifically looking at for steps 4 to 5. What value of x makes this equation true? So this is the type it in, which it's designed specifically for you to make sure you know how to solve an equation. You can't just trial and error this. Now, if you end up having to trial and error it, that's a mistake. Just relax, leave it. Maybe something will happen where it jogs your memory later on down the line. Now, the first thing I notice is that I want to multiply to get rid of that fraction. And don't be worried about how I used brackets there instead of parentheses. It's just a different way to write a set of parentheses, really. In fact, if you'd rather write them that way, you can go ahead and do that. So I want to get rid of the fraction here. So I'm going to multiply everything in my entire equation by 4. Negative 1/4 times 4 is negative 1, so that's negative 1x. And I know I don't need the negative 1 in front of the x, just negative x would be fine, but I'm going to leave it there to make some of you a little more comfortable solving the equation. Minus 4 times 12 is 48, and on the other side, 4 times x is 4x, and 4 times 3 is 12. So now I have just a good old-fashioned variables on both sides equation, and we just did a whole bunch of practice with these. So we should be a lot more comfortable now than we were before. Now I want to look at what I've got here. I've got negative 1x and 4x. Negative 1x is smaller than 4x, so let's add 1x to each side, giving me negative 48 equals 5x plus 12. Subtract the 12 from each side. Sorry about the space there. Is negative 60 equals 5x. And in all of these individual spots right in here, it is perfectly fine for you to use a calculator to double check yourself. Just remember to always have in your mind what you think the answer is before you hit equals or enter. Okay, let me finish this up and then I gotta get to my door real quick for a student. Divide both sides by 5, we get negative 12 equals x. Remember to go back and check that before you decide that's your answer. So let me switch colors real quick. Negative 1/4 times negative 12 minus 12 equals negative 12 plus 3. Is that true? Negative 1/4 times 12, and negative times negative is a positive. 1/4 of 12 would be 3. 3 minus 12 would be negative 9. Over here, this is negative 12 plus 3, which is also negative 9. Ta-da! Correct answer. Negative 12 is our answer. And another inequality. Remember, if you're not pausing it, pause it now. So I automatically notice on this one, because you've got the 1/2, that I'm going to multiply everything by 2. You know, another way to think about multiplying everything by 2 is doubling everything. So let's, instead of thinking about multiplying by 2, let's double it all. Double, double, double. Holy crap, that just got so much easier. Minus 42, minus 42. So the x is going to be on the right-hand side, which I have an issue with, but that's okay. So now I know what I have to do because I kept it simple and I wrote it out the way we learned. So that's the greater than or equal to sign, and that's negative 30. So it's x is less than or equal to negative 30, or negative 30 is greater than or equal to x. So remember, find a fraction, multiply by that LCD. Or in this case, the only denominator. Identify each integer. So what's the common mistake with this? What's the very, very common mistake with this? The mistake that I usually see is that you guys go, negatives, negatives, negatives are integers. And that's all you circle. Well, no. Integers are number line numbers. So if you can remind yourself, as soon as you see integers, to draw yourself a number line, to remember it's the number line numbers. Let's draw a big, giant I number line. Okay, there's 0. So big I for integers. See it? So if you remember that, you'll be able to say, oh, that's a number line number because that's 6. That's not. That's not. That's a number line number, and that's 25. So those are my 3 integers on that particular problem. Which set has a domain of 2 and 3 and a range of 5 and 8? Well, remember, we have ways to remember this. Domain and range, x and y. So your domain is your x's. X of 2, 3, 3, so that one's good. Y of 8, 5, 0. It's not A. 3, 2, 3 for the x's, that's good. 5, 5, 8, that's probably our answer. 5 for an x, that can't be right. 8 for an x, that can't be right. As long as I know the definition of domain and range, that question is super simple. Which table of values is represented by this rule? 2 and 6/10 times a number x plus 5 is y. And all I did there is take what I was reading in that sentence and translate it into algebra. 2 and 6/10 times a number x plus 5 is y. And that's it. There's your whole answer. So, there's what you need to find your answer. So part of this requires me to recognize that a decimal can be a coefficient, and that's okay. You're allowed to have a decimal be a coefficient. Now what I would do is go through, because all of the tables have the same 2 numbers, and I'm going to make a table for my little equation that I wrote. And I can do that just fine on a calculator, but I'm going to write it out anyway so that I can see what I'm doing. 2.6 times 2 plus 5, and also so you guys can see what I'm doing. 2.6 times 2 is 5.2, plus 5 is 10.2. So when you plug in a 2 to our equation, we get 10.2. My choice is A is wrong, D is wrong, C is wrong. We're done. Let's double check it by plugging in 5. 2.6 times 5, 2.6 times 5 plus 5, that's going to be 13, plus 5, that's going to be 18, and we could think of it as 18.0 to match answer choice B. Okay, don't forget, pause it and try them. If you're not doing that, then this is kind of pointless. You're not going to retain as much, guys. Which 2 angles are complementary? Complementary. I need to know what that means. I know what that means. That means adds up to 90. So I need a pair of them that add up to 90, and I know n can't be any of them. Okay, 71 and 71 would be congruent. 71 and 109 would be supplementary. So I probably want a combination of either M and P or Q and P. So M and Q, no. N and P, no. P and Q, probably. M and N, nope, P and Q. And P again is 19, Q is 71. That does add up to 90. All right, that's it. That's the last math question I'm going over in this video. Let's take a look at this last slide, and we'll be done with our video. All right, so your last minute reminders here. Think concept, not algorithm. Do not get bogged down in the how do I do this? How do I do this? Instead, think about what you're actually looking at. What is that equation saying? What's happening to x? Or in a proportion problem or a percent problem, what are you actually finding? Are you finding what you're paying, what you're saving? Are you finding interest? Are you finding total? Or, if you're dealing with a word problem, what are you actually finding? Write it out in a non-conventional way. Of course, I want you to know how to do the math the, quote, correct way, unquote, but that's not really the point of this test. The point of this test is, do you understand the concepts? The concepts. When in doubt, write it out. Don't be a jerk. Check your work. These are all cute little sayings that probably would help us when we're taking the test. Let the calculator be your helper, not your guide. Do not only punch the calculator buttons. Write it down, write it down, write it down, write it down. I want your hand to be tired at the end of that test. In the end, just do the best that you can. You will regret anything less than that. You will regret any effort that's less than your best. I have faith in you guys. See you in class.